Hello.
Hello.
I feel like we went from wrapping up SCF meeting to RPCiege, which has been really fun.
We're just rolling all the events.
I know. We've been nonstop going at it.
Good.
All right, let's end the RPC, or sorry, not end the RPCiege event, but we will get started on the RPCiege event. Cool. It is now live.
Sweet.
Sweet. All right. Hi, Tyler. How are you?
I'm doing super. How are you, Anukia?
I am great. I see folks are starting to come in here. Hello, hello, everyone. How's it going?
Nice to
Um,
see y'all.
I know. I love it. I guess we'll give it a few minutes before we get started here, while we wait for folks to hop in. Are we live on Discord as well, Tyler?
We should be. I just started up. If people want the opportunity to jump in to ask questions over audio, we're gonna get a little risky with it. And there's gonna be an audio channel in Code Cave, which should be feeding into the stream. So if you have the permissions to talk, you can feel free to jump in there, and I'll also be monitoring chat from there as well.
Absolutely. Sounds like hello, hello. No Tylenol for you today. Let's go, go, go. Exactly. It's been back to back
He's
today
healed.
events. I know. We love it. Um, Great. So I guess Tyler will give it like another 3 minutes before we kick it off. But in the meantime, since this is the first time we're actually streaming to Twitch and YouTube at the same time, let's do quick intros. Who are you, Tyler? What do you do?
Yes, who am I and what do I do? My name is Tyler Vanderhoeven. I'm a developer advocate at the Stellar Development Foundation. I've been here for a little over 4 years, but I've actually been building Stellar apps since 2014. So we're coming up on the decade of building
Wow.
Stellar applications, which is pretty wild.
Yeah.
Started out in what was the Stellar community, the Stellar Build Challenge, which then kind of
Uh,
one way or another morphed into the Stellar Build Challenge or Stellar Community Fund.
mhm,
Just building lots of apps, writing documentation, blog posts, having a good old time. Um,
mhm.
Early on, I was working for another company doing business analytics, so started out doing design and front end development, graphs and charts, jQuery,
Okay.
D3, things like that.
Yeah.
Um, then kind of moved into full stack development, wanted my apps to actually do things, and also wanted to be able to do microtransactions. We were working with a lot of Stripe and PayPal APIs, and
Hmm.
they're really hard to do microtransactions with. So that was kind of
Hmm.
my initial interest in blockchain and crypto. And
Blockchain, crypto.
uh,
And
the
then
rest is
now, what do you
history, as
do?
they say. Now I build code games and hang out in the Discord and build
Yes.
weird applications that test the limits. I like to say
Break
most
things? Or...
most companies test the happy path and the sad path, and I like to test the crazy path. All
Mm.
the wild things that people might do with different technologies, and
Yeah.
help product teams figure out their roadmaps, covering all the edge cases and wild things that people will do. Uh,
Yep.
this next year, we're planning on doing a lot more video content, so
Mhm.
you might see my face a little bit more, at least maybe my cursor and keyboard typing some things out. We'll see. We're still planning out all the content, but
Yeah.
I've been asking folks what they'd like to see, and it seems like video content's pretty high up on that list.
Yeah, we just had that conversation in the SCF meeting as well about how we would love to just search up Soroban and get a plethora of video content, right?
Yeah.
And that's something that would be, we want more ideas. So if the community has ideas, please do share. I keep asking. So yeah, that's one way for us to build Soroban into a better ecosystem, more stronger one, and more widespread as well. So yeah, let's get started, Tyler. I'm gonna disappear and let you take over the stream and let you lead it. Cool?
Cool. Yeah,
All
absolutely.
right.
Fair warning, I'm getting over something, so if I start hacking and coughing and dying, feel free to mute me, take off my camera, and take over for me,
Absolutely.
because there's a non-zero chance that that will happen.
Okay, great. I look forward to it.
Good. Don't. Wait, what? All right, but we'll go ahead and get started. Today's task is to work through our skirmish 11 and skirmish 12. So I'm going to be providing my code answers for those, kind of walking through how you would solve these two skirmishes. So yes, this is cheat codes for solving those past two skirmishes. And then if you stick around, I'm going to provide a life-saving, sanity-saving link for tomorrow and Friday's skirmishes, which you will thank me for. Your deranged self will thank me for if you stick around for that. So let's go ahead and tackle skirmish 11. So we've been doing RPCiege, walking through lots of different Soroban, Rust challenges. Some are more puzzly than others. This is a bit more of a puzzly one. We've got a nice story narrative that we're following through, kind of ties in with some older Soroban quests that we did. We're also giving away XLM rewards for these four skirmishes, so that's a fun addition to the RPCiege. For the task on skirmish 11, though, basically all we're trying to do is what it says right here. We're trying to create a smart contract, a Soroban smart contract, that all it has to do is store two items in two different storage types. So there's a instance key or instance storage key and a persistent storage key, and then it needs to successfully bump both of those. So within Soroban, we've got this concept of storage archival, where data does not just by default stick around forever. You need to bump it to keep it from expiring or from archiving. And then you also, if it does go into archival, you'll need to restore it. And so that really the whole Siege 5 here, skirmishes 11, 12, 13, 14 are all involving this concept. And this is not, if you're struggling here, you're not alone. This is a very unique, special concept for Soroban, really for all of our different blockchains, solving this really difficult problem of state bloat. As people put more things onto the ledger, how do you just keep it from ballooning out of control, where you're going to need monster machines to be able to run anything, and it's just going to become way too expensive to keep the chain going. You have to find a way to prioritize stored content, put things into some sort of cold storage, or evict unused or unnecessary content altogether. And within Soroban, you've got this types of storage that are going to solve that for us. Two of them being instance and persistent, and then we've also got a temporary storage. We'll talk a little bit more about the three different types in the next skirmish, but for this one, all we're really trying to do is store two keys, one with instance, one with persistent, and then bump them. Bumping essentially saying when a ledger number, so there's the blocks move forward, the ledgers move forward and continue to increase. Eventually, every stored item in Soroban has an expiration or a archival date or ledger number, and once it hits that, it's eligible to be archived. And if you want to increase that number, you need to submit a bump operation or a bump method within the contract to say, hey, this particular key, I want to bump it forward a few ledgers or however many ledgers. And so that's what we're going to do for this contract. So I'm actually going to I'm going to start a brand new project. So I'm going to go really quick over in my other screen here, weird flex, and just do tempt skirmish 11. And then I'm going to open that up in my VS Code. And then I'll pop this up over here. And then I'm just going to walk through this whole process. We'll go to Soroban docs. And I'm really hopeful that we'll get a CLI command for like Soroban new or something like that with some templates. But for now, what I like to do is go to the Hello World contract and just copy there's a command up here somewhere. Yeah, this one, this is probably the command I should have used instead of creating a new directory, but let me pull over a new one of these terminals, and I'm just going to go into the desktop where all good projects start. And I'm just going to start this here. I'm going to delete my old one. So instead of, because this new command will create a directory for me. And then I'll change directory into that. And then I'll open that up in my code editor. And that starts us with a nice boilerplate project. And then I'll come back here. We're going to update our cargo toml. To this right here. And then I know a little bird told me that we need to make sure we pin this to a specific 20. I think a lot of us got caught. We're right in the middle of releasing all of our official release candidates, but those releases are not currently compatible with the FutureNet or the test network that are currently live. So I believe cargo crates are a little bit weird with pulling the right most recent version of a thing. So 20 is the one that it currently says, and we actually need to make sure we're still using this release candidate, not version 20. And so we need to explicitly pin to that release candidate. Excuse me. Good. Go back here, and there's finished code for our Hello World example. I think it's right here. So we'll just copy this into the library, and then we need a test file right here, and we're almost set up. Go back, and there's our test, and let's go see if our test passed. We'll let the Rust analyzer analyze all this, which will give me a nice little test runner, which I can run real fast. Is this large enough for anyone? I don't know exactly where all the chats are happening, but I've got one in Discord inside of Code Cave, and I'm also got this one inside the StreamYard that we're using. So if anybody has any questions or needs help with anything, make sure to either leave a comment there in Twitch or over in the Code Cave chat in our Discord, and I can answer those. I'll try and keep an eye on those. All right. Move this over here real fast. All right, so that passed. That's great. But that is also not in any way, shape, or form what we actually want for passing the challenge. So for this one, all we need to do is make a singular function. I'm just going to call this run instead of hello, which will immediately break our test, but I don't care at the moment. And then what we need to do, as per the instructions, is simply set a key for instance and set a key for persistent, and then bump both of those. So we don't need to return anything from our function. We just need to set the environment, and then there's a storage option, one for instance, and another one I'll just do set, and then this key can literally be anything. So I'm going to do a nice, the best number, 0. And then we have another one, environment dot storage persistent, and we'll set that to the same thing. All right, so now we've set both of these keys, but then there's also the option to bump these keys. So that's what we need to do. So we'll start with instance bump, and now we get the wonderful experience of trying to figure out what in the world a low expiration watermark and a high expiration watermark is. If you spend much time in the Discord searching the word watermark or bump, you will find at least one, if not many, massive threads where we discuss what in the world we're supposed to call these things to make them intuitive. And rather than spend 30 minutes trying to explain exactly how this works, I would suggest that you go and find those long chats, because they're very informative and will provide a lot of interesting context on exactly what's happening here. But essentially, the long and short of it is, not every time that you include a bump method or a bump function is it actually going to bump. It's going to look to see if the bump is within parameters. And so if it's within those bump parameters, it will actually perform that bump, which is worth knowing. It makes it a little bit safer to include numbers here, knowing that you won't actually pay the fees for bumping unless there's actually a bump that happens. Now, as per the instructions that I called out, which would have caught a few of you, it won't be sufficient to merely include bump calls in your contract. They need to actually occur, which means we're going to have to be very intentional and very careful with these these values, which I'll get to again in just a minute. Let's go ahead and just leave those for now, and we'll do a persistent bump. And my Copilot has incorrectly set these. We need the keys. So instance, you might already be kind of starting to figure this out, is actually storage that's directly attached to the contract itself. So it's any storage keys or items you sent are set are all within this large instance object. You can think about it as kind of just a singular instance object, all of the keys you put here. And this includes actually the contract code ID as well. So you got to be a little bit careful. This is where it starts to become important, where you think about, where do I store some? When would I use instance? When would I use persistent? When would I use temporary? So something to keep in mind with instance is anytime you do a get, anytime you do a set, anytime you do a bump, on instance, it actually pulls down and updates the entire object. You don't actually bump or set. I guess you set individual keys, but it updates the entire instance object. Whereas with persistent, you can deal with individual specific keys. So when you get those or set those, bump those, it's just dealing with that singular key. It's a little bit more expensive to set, but it'll be cheaper to get and bump because that size might be much smaller. So if you've got a large set of data, you probably are going to want to use persistent or temporary rather than instance. Okay, we're not actually use temporary because typically, very much, I don't know why you would want to bump other than maybe an initial bump, but typically you're not going to bump temporary storage. Temporary is really this idea of once it's expired, it's gone forever. So you might use this for a nonce key or a really short-lived signature key or something like that. Not something that needs to hang around for a long time, or that you need to ensure can be bumped because it can't ever be restored. It doesn't go to an archival. It just gets evicted or kicked out. Excuse me. All right, so let's talk about these low expiration and high expiration watermarks. There's a essentially, so the way that it's worked for me, and again, I'm no expert in this. I'm still trying to figure out how this works myself. But in order to ensure that every single time we call this run function, these bumps will actually happen, is to essentially bump these to their absolute max. And all of the networks that you execute these on have maximums that you're allowed to set for the high expiration watermarks. And high can't be lower than the low expiration watermark. So you really want to go and find what's the networks that I'm executing this on maximum entry, lifetime, or expiration that we're allowed to set. So instance and persistent, I think, are the same, and then temporary's a lot shorter. And how I found these is actually in Stellar Core. There's a upgrade script that they use whenever FutureNet is, I guess now in testnet, or reset, where they set all of these values. I'm going to share this link in the code cave, but then I'll also just put this up on screen. And so it's inside Stellar Core, there's a scripts, Soroban settings, and then there's this upgrade script. And inside here, and everybody's like, well, where would I ever find this? I think it's kind of included in the Soroban settings, but it is a little bit obfuscated. And again, most of the time you may not need to know what the max is for this, like actually, it'll be sufficient to just call it once, because there's a default low number that is set. I don't know, it's like 4 hours or something like that. And then after you set that low and high expiration watermark, once you've initially bumped it, then it'll have bumped it to its max. And so if you're trying to bump it lower than that, this bump won't actually occur. But if you're always setting it to the max, assuming you always call it one ledger after, it should be bumping. And of course you have to set it one ledger after if you're using the same source key. So if none of that makes sense, the value that you need to set this to ensure that every single time you call this it works is this ledgers per day, and then this max entry time to live, which is basically 31 days of ledgers based on an assumption that there's 12 ledger closes per minute. So it's this times 31. And so I'm going to set up here a constant variable of max entry lifetime. And this is going to be a U32. And that was 12 times every minute for every day times 31 days. And then we can set these here. Now, if we set this, this is probably actually going to error because I think this max entry, if you called it in before, I think this is like one ledger too high, because I think it's when you actually set this, it's inclusive of the current ledger or something like that. So again, when I was testing, if I just used this, it would fail every time saying that max entry lifetime was too high. But if I just decrease that by 1, it worked every time. So we can set that, and then we'll delete these bits we don't need anymore. I'm not going to worry about setting a test for this because this is a very simple contract. I'm just going to look over this again really fast. We don't need symbol either. I think we do. Well, there's one more piece I guess we're missing, and this is an important one if you want to collect your NFTs. And RIP if you forgot, but you have to include your NFT destination argument as per the early instructions, and I like to include this as an optional address, so that I don't have to include it while I'm testing, but that's optional. You can, of course, enforce it if you want to. And then it doesn't have to be this argument name. I mean, you could call this Bob for all I care. You might want to underscore it because otherwise the ID might yell at you a little bit. Okay, so I think that will get us all of the way there. I'm going to go ahead and Soroban contract build this. Which will go through and build this contract out for me. And then I'll deploy it. And I actually have an RPC running locally. So we always test on the RPC network, or RPCiege network, sorry. Usually I test on the live one because that one actually goes to the public network with your NFTs. I'll be testing on a local version, which you'll see again in just a minute. But actually, I guess I can pull that in. So I use Cloudflare workers for this. And so I've got a nice little Cloudflare worker interface here, and we'll get to see us attempting to pass this game. Alrighty. Soroban contract. Did you guys know there was an optimize function? Pretty nice. Target. WebAssembly release, and then this is probably called Hello World now, isn't it? Oh, no, project name. Amazing. All right, and then we get this project name optimized WebAssembly file. Look at that, it shaved a couple dozen bytes off for us. Soroban, contract, deploy, WebAssembly, target, WebAssembly, release project name optimize WebAssembly network. We can deploy this to FutureNet. We really only need to use the RPCiege when we're actually trying to get our NFTs. RPCiege proxies straight to FutureNet, so we can just deploy this straight to FutureNet. This will give us a contract ID, which we can use to attempt to pass the game. All right, there's our contract address. So now we do Soroban. This is probably tiny for you guys, huh? Let me type 1 in the chat if you've got young eyes. Soroban contract run.
Do you think you could make it a little bigger, Tyler?
I can keep hitting the command plus until the cows come home.
That's about one. Okay.
There you go. Soroban contract run. Oh no, invoke ID. And then let's run, let's actually execute this on a particular network. And this is where we're going to want to use RPCiege local. Again, I don't know what you've put in for your network address, but this is the RPCiege network that I've connected. So Soroban has a config option which allows you to set up identities and networks. And so you can hardwire in the RPC passcode, passphrase, and URL. And so I've done that, one for local and one for live. So I have this one while I'm testing. And then we'll just take a look and see what functions we have available to us. We've got this run. And then there's our NFT destination, which is an option, but I don't actually have to include it. So I think we can just hit run. And then we should see up here, which again, I can, oh my goodness, make this a little bit bigger. And what we'll see when we hit run is we'll get some requests that get sent over here as the transaction is submitted. And then it begins to ping the network to look for the response. And assuming that we passed, we should see game 11 complete. We also passed game 1 because game 1 is just to invoke any contract. And so congratulations, you also pass game 1 when you pass any other of the games. But then we also passed game 11, which means we did what we were supposed to do, where we set the keys for instance and persistent, and then we also successfully bumped. And we should notice that if we run this again, it should complete both of those. Whereas if these bumps were a little bit smaller, I don't actually think game 11 would always complete, because these bumps wouldn't actually be executed if they weren't right on the edge of maxing out at their highest values. Okay, fantastic. So that is game 11, skirmish 11. I'm going to take just a moment to look through this chat and make sure I haven't missed anything, and then we'll get right into 12. And hopefully, so yeah, there's a couple people talking about this bumping thing that's always confusing. Hopefully we'll get some better docs on this. CC ping Elliot to help us understand how in the world bumps actually work, because I've tried, and every time I'm like, okay, so what you're saying is, and then I write out this thread, and then I get the reply, well, not actually what you really need. Like, okay, I'm lost. All right, cool. Looks like everyone understands perfectly, because all of you are absolute geniuses. All right, let's go ahead and get back into the desktop. And then we'll build out 12. And we'll, that's not what we want. We want to CD into 12 first. All right. I'm just going to real quick bring these up to speed with what we already had here with our cargo toml and our library. I'm not going to include the test this time. I'm actually going to nuke that because I have a slight OCD problem. Okay. So now I think we're good on that front. I think let's keep project name because that's, let's be honest, the most incredible project name. And then let's go back here and take a look at our next skirmish. Skirmish XII. All right, so this one I thought would be a little bit more straightforward, but a couple of folks Robert got caught trying to figure out how what these keys actually were. I saw some people trying to use strings. A couple people were able to solve it, but I'm going to go ahead and walk you through what this was supposed to mean, and it remains to be seen. History will tell if I should have provided a little more guidance here. But your ... here should have been all the clue you needed, but hey, it's RPCiege. We win some, you lose some, especially when you're doing it at 2 a.m. or 4 a.m. or, you have a fever of 100, etc. Okay, so again, I'm going to switch over to my cheat sheet, which you can't see, which makes me seem like I'm really smart and know everything by heart, but you'll notice that I look over all the time because I don't. I actually just copy these things. That's skirmish 11. We are not doing that one. We're doing skirmish 12. Okay. Delete all that. All of the rest of this stuff stays exactly the same. We don't need this. The rest of this can stay. So all we're trying to do is store those keys into their relevant storage types. So again, there's 3 different storage types, and we want to store these 3 different keys into what would make the most sense. So yet again, I'm going to do storage. We'll start with instance set. We'll leave this key and value for now. Copy this 3 times. Make sure we've got the colons. Very important to have those. And we'll do persistent and temporary. And now the keys here are and station instance, and then we can store whatever kind of value we want. Let's do true this time. Use a nice binary value. Station persistent and station. Do y'all like my little rocket? There's a rocket plugin that I can't figure out how to turn off for this, but I love everywhere else that lets me put in emojis all over the place. Anyway, temporary. All right, so that's looking good. We need these all to be true. Try true. Oh my goodness, I did it twice. All right, so now we're getting failures here, and this is where some of you tried to use strings. Which, to be fair, that's not the worst idea, but we do have this concept in Soroban and Rust of custom types. And the one that we're really looking for is enums, where we can essentially just set these singular values. They can have arguments if you want them to. Ours doesn't need one, but this is what we'll be using. And I hope anybody who is like stuck here all of a sudden is like, oh, you gotta be kidding me. It's so simple. Quick fix. Contract type. And then we need one called instance, one called persistent, and one called temporary. And look at that, ladies and gentlemen, we did it. And I'm almost positive, once again, that this is all we need. We'll go back over to our terminal. We'll do Soroban contract build. Not going to compress this time because, let's be honest, this is a tiny contract already, but it's good to know that the Soroban CLI has a optimize feature. If you're getting an error when trying to do optimize, you need to build your Soroban CLI with the optimize feature enabled. You just need to go when you're doing your setup and you're installing this. you just want to include a dash dash features OPT. Right, so one of these days I'll get it. There we go. I think it's features. It might be just feature, but I think it's features, and then you OPT, and that will give you the optimization feature when you install the CLI. And then that will allow the command within Soroban to actually build out an optimized contract. All right, Soroban contract deploy. WASM target, WebAssembly release. What was the name of our amazing contract? Project name. WebAssembly, and this is going to be on the future network. I need some tunes for when Rust is doing its thing, some nice elevator music. All right, there's our contract. Soroban contract. Invoke ID. Oh my goodness, ID. Network RPCiege local. Let's take a look. And there we've got run. And we should see that we've got, again, the NFT destination that's optional. We'll go ahead and omit that. And we should see ourselves run through here, and fingers crossed, we passed game 12. Fantastic. We could talk real quick about these different storage types. So again, and I kind of talked about this a little bit earlier, just in the natural course of conversation. But instance storage is actually stored on like the contract deployment. So this is where, by default, things like the WebAssembly contract hash. So when you install or when you deploy a contract, right? So when I do Soroban contract deploy, several things are happening, not just one thing. First, the WebAssembly file itself gets deployed or installed to the ledger, and what comes out of that is a SHA-256 hash of that WebAssembly code. And then when you then go and deploy a contract, you're not linking those things, or I guess they're not both installed in the same, like ledger key. When you install a contract, part of the instance, there's a key on the instance. It's the WebAssembly hash, and that hash is that WebAssembly that you just installed. So that actually goes on the instance. So any other key that you install into instance is like that. So this would be good things like admin keys, owners, things that aren't going to change very frequently or don't have a whole lot of data associated with them. So not vectors or maps, unless they're really small. That would be the only thing you'd really want to put in instance, most likely. Another thing to keep in mind, or that's kind of interesting, is whenever you bump that, everything gets bumped, right? So you're not bumping individual keys within that, you're bumping everything in that instance. So if I go in and I'm like, ooh, I really need to make sure my admin key doesn't expire or get archived, I should go and bump my instance. It's going to take care of everything that's in instance, so I don't have to worry about my contract hash association either. But it is also really important to remember that that WebAssembly hash is stored in instance, because if you don't use instance anywhere, and you're like, oh, I don't use instance storage, so I never need to bump it, you're going to have a bad time when your contract code key gets archived and your contract breaks because you never bumped that particular key. Thankfully, you can just submit a Soroban, or I'm sorry, a Stellar operation, which does that restoration of the instance key for your contract and bring it, rehydrate or bring it back to life, whatever. But it is important to keep in mind that there are some things stored in the instance storage vaults, if you will, by default. So even if you don't use it, keep it in mind. For persistent, this is kind of like your traditional key value database, where each key has its own value, and you need to remember those keys if you want to keep them bumped. So you might want to bump them just through the natural life cycle of contract invocations happening. You might want to set up a watcher that looks for any time a key is set and stores that somewhere, so you can run like a cron task that just keeps bumping those so they don't expire. Maybe you want them to expire. That's obviously why this is built, so you don't bloat up the ledger with things you don't need, which is one of the reasons it's good to keep persistent entries getting bumped as the contract actually gets used. But there may be instances where you can't bump long enough on something that, maybe needs to, like an escrow account or something that's not going to mature for 5 years, and you might want to keep that bumped even though it's not getting used consistently. And then last but not least, you've got your temporary, which I really love, but it isn't going to get used a whole lot in the contracts I've built. But it's amazing in that you can't restore it. So it's intended to be this really like short-lived, ephemeral key, because there's just so many things in blockchain that don't need to exist forever. Order numbers or nonce keys or dates, things that exist only for the life cycle of a particular transaction or maybe a short-lived transaction set. And once it's gone, nobody cares what it was anymore. And so it's almost like admin or auth keys or something that you roll every month or something. This can be a quick rolling auth key. Who knows what you might want to use it for, but the idea is here's a good place to put really cheap storage that is intended to just get tossed out whenever its purpose has been served. And so those three different types. You'll want to use them for different things, but just be aware of those. Temporary is obviously the cheapest. I think persistent is the most expensive. There's a good doc on the costs of all of the storage. I think it's actually in fees and metering, I think, where you've got different types of persistent and temporary storage and how those things stack up for cost. So you can see that persistent storage is far more expensive than temporary storage. Oh no, that's persistent. This would be persistent versus temporary. So where you can, temporary is a good option. All right. Fantastic. So I also promised that I was going to give a little bit of a clue for tomorrow's challenge. Now I'm going to give you, I think this was leaked a little bit in the email, not the link, but what's coming up. So what is coming up is there are two other ways to do bumping and restoring. Well, there's actually only one way to do restoring, and that's in a transaction, in an operation, a stellar operation restore. So you might be familiar with when you actually execute a Soroban contract, you're actually using a stellar operation. So it's like the world's most powerful stellar operation in that it can do anything. But there are a couple other Soroban related operations. And one of those would be a restore footprint op. There's another one for a bump footprint expiration op. And these are the two that the next 2 days, Thursday and Friday, are going to be on. And they are doozies because they're hard. They're not simple. And I'm going to be honest with you, this code snippet does not work at the moment. We've been moving fast and breaking things between the SDK and the different releases. So this code here looks like it would work great, right? You just get the footprint, you set it in there, you build your transaction just like you would a normal stellar transaction. But last I looked, this does not work. And so you're in for a world of hurt when you try to use this code, like I was a couple of weeks ago when I was building out these challenges. So fair warning, this is a good place to start, for sure, to find the errors, to find the issues here. You can hear my voice going. But this is going to be very broken. However, all of the cheat codes you could possibly want are publicly available in our Discord. There's a thread that I authored in desperation. I say authored as if I actually found the solution. Well, I guess in some ways I did. But through much help and trial and error, there's a forum post inside of Soroban help that I started. And that's always like that, like a massive pro tip. Whenever you're doing a siege and getting stuck, just go into the Discord and try and look for anything that I authored around that or relevant to that, because chances are, if you're having trouble, I had trouble. And I asked people in the Discord to help me. And this is one of those cases where there's a thread that talks all about using the JavaScript SDK to do these bumps and restores, and it wasn't working. And I'm going to tell you right now, there's all the code you could possibly need to bootstrap, get yourself ready to actually do the next two challenges. So that's your reward for listening to me ramble for 40 minutes about RPCiege. You get the nice head start on how you might actually solve the next 2 days. And it's awesome, right? Being able to do Soroban things just through Stellar operations is really cool. Knowing how to craft Soroban transactions like by hand is also really cool. Like learning how all of this set Soroban data works, the different operations that are available are a bunch of fun. You've got things like, I guess prepare transaction does two things. It simulates and assembles a transaction, but there's lots of different helpers that are available in the SDK now for Soroban related transaction, like simulate transaction and assemble transaction and prepare transaction and submit transaction, or send, I think, transaction. And knowing how to fiddle with all of those bits will help you a ton when you actually start building out dApps and are trying to understand errors or optimize your fees, all that stuff. Knowing how to use the SDKs to build those things rather than always relying on just the CLI or just the simulation endpoints to do these things for you. It's like a superpower, and it also doesn't feel like magic anymore. You understand what exactly is going on behind the scenes, which was a massive unlock for me in understanding how Soroban actually works. So it should be a lot of fun, even if it is a little bit of a headbanger initially. I think that is all that I have. I will look back through the questions really quick and see if there's anything that I'm missing. I don't know, Anushya, if you caught anything that I need to be aware of. Kanye shared some good links. That's good.
There were a couple different links shared, Tyler, and nothing crazy. No one really hopped in.
Yeah, Soroban developer. Yeah, Morgan's like, you could just memorize the XDR, do it the hard way. Expired temporary storage sounds like a good recipe for a quest. All right. Well, fantastic. I feel like there was something else I wanted to call out here, but I think that's probably all we have for now.
When is the next siege, Tyler?
The next siege, that's a good question. The next siege happens at 9 a.m. Eastern Time tomorrow.
Sweet.
So 9 a.m. Eastern Time tomorrow is when the next one goes live, and then I think it's 1 p.m. Eastern Time on Friday for these next two.
Great.
These next two sieges. So be sure you're ready to quest. Go for those top slots. I expect to see my Robears and Venomos top the charts as per usual. Appreciate you guys playing. Definitely expect more video content. Seeing my beautiful face all over the place more next year. Should be a good time. I'm excited to do more
video
more content.
Streaming.
Yes, sir. Absolutely.
The husky voice.
Oh yeah. Goodness, I need to get rid of this. My voice is killing me.
I do also want to share, everyone, that we have another stream tomorrow happening at 2:30 EST, where Okashi Morgan, our very own Soroban developer on Twitch, is also going to be doing a stream with G from SDF internal as well. So yeah.
Sweet.
All right.
Very exciting.
That is a wrap. Yeah, I think that is everything, right, Tyler?
I believe so. Love you all.
Okay, great.
Thanks so much for watching.
Bye, everyone. See
We'll
y'all
see you
soon.
around.
Bye.